Hello, in this episode we are going to mention how to build machine learning models with LightGBM framework. As a dataset we are going to use this golf2.txt file, and as seen, this is a simple dataset. It includes golf playing decisions, yes or no, based on some features. Here some features are nominal, such as outlook or wind, and some features are continuous, such as temperature and humidity. I'm going to import pandas to read the dataset, pandas.readcsv, and I'm going to pass the name of the dataset. It's going to be golf2.txt, and it's going to be my data frame. Let's see the content of the data frame. Head function returns the first 5 rows of the dataset. LightGBM expects you to transform nominal features into numeric ones. Here we can find the column names, dataframe.columns, and let's build a for loop in data frame columns. Let's print the column name first. Here we can access the data frame column just like that. Data frame, and in the parentheses we will pass the column name, and we wonder the data type of this column. As seen, some columns are object type and some features are in integer type. We have to transform object types into numerical ones. So here we need to check the type of the column, and if it's equal to object, then we have to do some transformation. I'm going to import scikit-learn's preprocessing library. Import preprocessing, and here I'm going to create a label encoder, and it's equal to preprocessing dot label encoder, and we are going to apply label encoder dot fit, and here I'm going to pass the object column type in the data frame. After that I'm going to call label encoder dot transform, and again I'm going to pass the object column here. This is going to be the encoded feature, and I'm going to transform the encoded feature into the data frame, and this is going to be my neb column. I deactivate the print column and run this block. Now I'm going to check the data frame content here. As seen, nominal features such as outlook and wind were transformed into numerical ones. Now I need to split the data frame into features and target values. Here the target value is stored in the decision column. That's why my target is equal to data frames decision column, and features are stored in the other columns. I can drop the decision column just like that. Columns is equal to decision. In this way X will be outlook to wind features, and here I'm going to call values command to transform the pandas data frame into numpy array. You can see the content of the X just like that. These are my features and these are my target values. They are all in numerical type. Now it's time to modeling. Here I'm going to change the type of this cell from code to markdown. Here I'm going to import LightGBM first as LGB. Here the both X and Y, in other words, features and target values are in type of NumPy array. We can check it just like that. Type X and type Y is also in type of NumPy array. We will convert these NumPy arrays into LightGBM format. LGB.dataset, and here I'm going to pass features and target values as first and second argument. This is going to be LGB train. Let's see the content of the LightGBM dataset. Here we can pass categorical feature as input argument, and remember that the both outlook and wind are categorical features in my dataset, but here X and Y are NumPy arrays and they don't store the column names. That's why here we can pass feature names as input as well. Feature name, and this is going to be the columns of the data frame, but we should not include the target value. That's why I'm going to call data frame dot drop and columns drop decision target value. This is going to be LightGBM train dataset. Now I'm going to create my configuration parameters, and it's going to be a JSON array. Here boosting type will be gradient boosting decision trees. Secondly, my objective function will be multi-class, because this is a classification problem. Remember the base dataset, its target values are yes and no classes. On the other hand, if your dataset has numerical target value, then you should define the objective function as regression, just like that. This should be regression in that case. Number of classes in my dataset is actually equal to data frame dot decision dot number of unique values. It's equal to 2. Alternatively, we can get unique values and get the length of that array. This is going to be 2 in my case. Here I should also define metric, and it's going to be multi-localhost, because this is the multi-class classification problem. On the other hand, if your problem is a regression problem, then you should define the metric differently. In that case, for example, root mean squared logarithmic error could be a metric for your regression problem. Normally you shouldn't pass mean data parameter here, but in that case the dataset is very small. That's why I'm going to pass mean data is equal to 1, and this is going to be my configuration parameters. Now it's time to train. You can build your LightGBM model, LightGBM.train, and here you should pass your parameters, then your train set. My train set was LightGBM -train. Calling train function returns an error. I actually know why this error occurred. Here, remember the column names in my base data set. Here, temperature column is specified with dot character. That's why LightGBM training function returns an error. Here we can pass this array, but I remove the dot character and call train function again, and it's completed successfully in this time. Our GBM model is built. Now we can make predictions, and here we can pass our input features, and that's going to be our prediction set. Let's see the predictions. It's multi-class classification problem. If 0 index value is greater than the 1 index value, then it's going to be no. On the other hand, if the 1 index value, for example in the third line, is greater than the 0 index value, then this is going to be yes decision. Let's build a for loop here for prediction in predictions, and print prediction first. Actually it's an array, it's a numpy array actually. Here I need to import the numpy, and here I'm going to check numpy.argmax prediction. Let's print it first. For example, the first line returns 0 and the third line returns 1, and I'm going to say if this is equal to 0, then decision will be no, otherwise it's going to be yes. Actually this is going to be my prediction, and I define it as P. Let's print the prediction here. We actually have the actual values in the y variable. These are zeros and ones as well. Let's create an index variable here and initialize it as 0, and in every loop increase its content. And here I need the actual value. Actual value a is equal to y arrays indexed value, and let's print whereas actual is a prediction. By the way, a is a numeric value here. That's why I'm going to check the content of a here. If this is equal to 0, then a would be no, otherwise a would be yes. As seen, I print predictions and actual values for all instances in my dataset. It seems that all instances are classified correctly. Prediction is no and actual value is no. For example, prediction is yes and actual value is yes too. LightGBM also offers interpretable or explainable machine learning models. Let's see the interpretability section here. LightGBM framework .plot importance, and here I'm going to pass my GBM model. Also, let's see the input parameters. Maximum number of features, let's say 10. Actually our features are size of 4, that's why we are going to print all features in the feature importance graph. Store this in the AX variable. Now let's see the content of the AX. we need to call plt.show, but before that we need to from matplotlib dot pyplot as plt. Actually this should be import matplotlib. Then we can call plt.show function here. And as seen, these are the importance of our features. Outlook is the most dominant feature in my dataset, and temperature comes after the outlook. And wind is the third important feature in my dataset, and the humidity is the last. We can plot the build decision tree in similar way. LightGBM dot plot tree, and here we are going to pass the build GBM model, and let's store it in AX variable 2, and let's call plt.show again. It returns an error and says make sure the GraphViz executables are on your system. Here the path of the GraphViz is located here in my computer. That's why I append this to the path variables, and let's call this block again. That's the build decision tree, but it's very small. You can handle this issue just like that. Initialize the figure size here, and this is the build decision tree. I think we can see the content of it. This is the build GBM model in my case. So we have mentioned how to build machine learning models with LightGBM framework. Thank you all for your watching, and see you next time.